Hey guys, so instead of taking class time to fill out this sheet, I thought I would go through this with you as a homework assignment. We're kind of summarizing here everything that we've talked about and learned about fractions this year and reviewing some stuff that we didn't talk about in class that you learned as sixth graders. So general rule here, to work with fractions, we cannot change the overall value of the fractions we have. However, we can manipulate the fractions using a giant 1 to make them more flexible and comfortable for us. In other words, we can multiply or divide the numerator and denominator by the same number. You guys worked a lot with the giant 1 last year, so we're going to do an example. A lot of times we'll use the giant 1 to reduce fractions, and oftentimes you do this in your head. You don't write it down step by step, but I'll make the steps here visible just so you can see what's going on in my head. So to divide the numerator and denominator of the fraction by the same number. So an example is we might want to reduce 18/27ths because we notice that they can both be divided by a couple of things. So you might notice they can both be divided by 3, but we might want to think, is there a greater number that they can both be divided by? And in fact, they can both be divided by 9. So the greatest common factor we can divide by is 9 over 9, and that'll reduce this to 2/3. Now, if you did divide by 3 first, then you'd end up with 6/9, and then you'd notice, oh, I can divide by 3 again. So you'd eventually get to the reduced fraction just by dividing again and again. But if you identify that greatest common factor, you'll reduce the number of times you have to simplify. The variable example is just kind of generalizing all in all. So a times b squared. Another way to write that is a times b over b times c. And here we're just looking for a common factor so we can see, oh, these could both be divided by b over b, and that will reduce one of the b's in the numerator and one in the denominator, which gives us a times b in the numerator and just a c remaining in the denominator. The variable examples might be a little confusing, but as we move through this year, you'll get more comfortable with variables. I'm going to pause. Moving forward, let's talk about multiplying fractions. We're going to multiply across. When you multiply any number by a fraction less than 1, the result will always be less than the original number. And that's what we talked about in class. So a numerical example is if we multiply 2/3 by 1/9, we want to remember to multiply the numerators. 2 times 1 is 2. 3 times 9 is 27. And that would give us this 2/27ths. And if we think about it, if you drew a little sketch of what we've talked about in class, if you wanted to figure out what 2/3 of 1/9 is, we're really thinking about what is this portion of the whole. And if we think about how to say what amount this is, it's really, we'd have to break the whole thing up into 9 equal columns and 3 equal rows, and then we'd see that we have 20 pieces that are the size of 27ths, and 2 of them is what 2/3 of 1/9 equals. So this answer makes sense when we kind of add a visual as well. A variable example is x times a over y times b, and we're always going to just multiply both the numerator and denominator and simplify if we can. Cross-canceling, before you multiply fractions, one shortcut is to look for common factors in the numerators and denominators so you can simplify those before multiplying, and I've seen a lot of you doing this already. So some numerical examples would be, if we see 4/7 times 1/6, we might want to look for some common factors. I notice these can both be divided by 2, and if we divide 4 by 2, we get 2. If we divide 6 by 2, we get 3, and then we can multiply the factors that remain. So we've got 2 over 7 times 3 is 21. Again, if you feel uncomfortable with the shortcuts, it's okay to just double check your work and think, does 4 times 1 over 7 times 6, that's 4 over 42. Is that the same thing as 2 over 21? Yeah, that's the same thing. Those can both be divided by 2. So an example with variables is 2, hold on, here comes Malika. So an example here is 2a times b squared, and again, that's basically b times b. over BD. And that's just saying we could reduce this, remove that B and B to just get 2 times A times B over D. Another example, negative 5/12 times 3/8. I'm looking for common factors here. So I see, oh, 3 and 12, those have a common factor. They can both be divided by 3 evenly. So if I divide 12 by 3, I get 4. And 3 by 3, I get 1. And I'm just going to multiply what remains across. So that would give me 5 times 1 is 5. And 4 times 8 is 32. And then this is a negative times a positive, so I know the solution is going to be negative. Here, just generalizing, we're looking for common factors, so 12 and 4 can both be divided by 4. And, oh, if I divide by 4, that's not 4, that's 3. So 12 divided by 4 is 3 remaining here, and 1 remaining down here, which would give us 3 times 3k, which is 9k, over jk. jk. But I'm not just kidding. It's really jk. And then I've got a negative times a negative, so I know my solution here is going to be positive, but let's think about, can we reduce either of these fractions? This is kind of a tricky one. 3/32ths or times negative 24 over 39. And I see a common factor in both of these pairings here. So I see that 3 can be divided by 3 and 39 can be divided by 3. And if we divide 39 by 3, that would be 13. So, and then this 24 and 32, those can both be divided by 8. So 24 divided by 8 leaves me with 3. And 32 divided by 8 leaves me with 4. So now I'm really thinking about this as 1/4 times 3/13. And that equals 3 over 26 times 2 is 52. So 3/52s. I'm going to pause and just check my answer. I had to pause and check my answer just because I wanted to clarify with this strategy. It does work, but part of the reason that is because we're multiplying 3 times, well, let's break this down into 8 times 3. So 3 times 24. And then 32 is, we can think about that as 4 times 8. And then we're multiplying it by 39, which is, we can think about it as 13 times 3. So what we've got here with multiplication problems is a bunch of numbers multiplied together in the numerator over a bunch of numbers multiplied in the denominator. So if we identify that these both share a common factor, we can reduce by both of them here, cut out that 8. And here we've identified that they both have a 3. These two share 3 as a common factor, so we can reduce that, which leaves us not with, we're not saying 3/32 is equal to 1/4, or that 24/39 is equal to 3/13. That's why it looks confusing. But when you really think about what we're doing here, we're saying all of these numbers in the numerator are multiplied together to give us 3, and these numbers are multiplied in the denominator to give us our denominator of 52. So if we generalize that, we've got 6 times n over 18 times n to the 4th, which we can think of as n times n times n. And then when we simplify and notice a common factor here, we can change this to n to the 3rd. That just gives us 6 over 18 times n to the 3rd. And that is that. Okay, and then dividing fractions. We multiply by the, yeah, you got it, reciprocal, I hope you got it, of the second fraction. But let's look at why that is. So I'm going to draw a picture here with 2/3 divided by 1/6. Remember that we're really asking how many sixths are in 2/3. So let's say you've got a pizza, 2/3 of a pizza left over, and you want to know how many sixths are in it. Well, I know that if I divide the pieces in half, I'll have a size that is a sixth. Every third divided by 2 is a sixth. But I've got 2/3, and I want to know how many sixths. Well, that's basically like saying 2/3 of a pizza left by 6 pieces per whole pizza, since I've divided it into sixths, and that is 12/3, or 4 pieces left. I wanted to put pieces, but that's not really the problem. But if we remember that this is pieces per pizza, and this is the size pieces, there's 2 ways to look at this division problem. How many sixths are remaining in 2/3 of the pizza, or 2/3 times 6 pieces per pizza? Just keep drawing these examples or thinking through them to really make sense of that, and also memorize that multiplying by the reciprocal is the same as dividing by a fraction, but definitely keep wrestling with why that is and try to think of real-world examples to make sense of that, because it's a tricky concept for a lot of us to wrap our minds around. So in general here, we're looking at x over y. When we divide it by x squared, that's basically like saying we want to flip these two. So it's the same as multiplying by xy over x times x. And here we can simplify a lot of this because we have, we have 2 x's in the numerator and in the denominator. So, and we also have a y in the numerator. Oh, no, we don't. Oh yeah, we do. Now we have a y in the numerator. This is just the same as 1. Let me double check that and get back to you. I checked it. It is true. I'm not sure how I feel about these variable examples. You can let me know whether you're completely confused by them or not in class. So